Pure water is simply two hydrogen molecules bonded to one oxygen molecule. However, pure water is incredibly rare to find in our water systems. Pure water is actually not as desirable as you would imagine, as it lacks necessary nutrients and minerals found in our water supply through natural processes such as natural spring water or treatment processes. Unfortunately, though, there is a fine line between too little nutrients and minerals and too many. The EPA lists three big pollutants found in water: dirt, bacteria, and nutrients. Bacteria is the most concerning of the three pollutants and the most likely to cause harm to an individual. Bacteria is most often passed into water supplies through sewage runoff and animal manure. Similarly, nutrients enter the water supply through sewage runoff, but also fertilizer and agricultural runoff. These pollutants can cause harm to individuals if not monitored and contained. When testing water for quality, there is no test for good or bad water. Instead, you have to test for something in particular. You must know what to look for in testing water quality in order to gather useful data, and the most effective way of knowing what to test for is looking at the environment around you. The United States is an incredibly diverse country ecologically. We have forests, deserts, prairies, and more, all within our country's borders. Each biome presents its own unique challenges for water quality. The Pacific Northwest, for example, is much more likely to see bacterial contamination through animal waste due to the forests and streams that would be likely to house a higher population of wildlife than some other parts of the country. Similarly, the large prairie lands and agricultural hotspots of the country, like the Corn Belt, would be more likely to see contamination through pesticide or livestock pollution. The reality is that water contamination is inevitable, and water must at some point go through a treatment process. Water treatment varies from facility to facility, but the process itself is largely the same. The first step in treating water is called coagulation. This process removes all the sediment and debris that may be in the water through either chemical processes or physical screenings. Next is sedimentation, where the particles gathered during coagulation sink to the bottom of the holding tanks, allowing clean water to move on. Once the water is clear of sediment and debris, it is passed through the filtration process. The most common types of filters used are gravel, charcoal, and sand, though filters and methods vary from facility to facility. Filtration further cleans the water and removes any particles coagulation and sedimentation could not. Finally, disinfection occurs, where some form of chemical disinfectant is used to remove any microorganisms or bacteria present in the water. Most often, chlorine disinfectants are used. After this treatment process, the water is either stored or flowed back into the water supply, where the process can begin again. Water treatment is an incredibly expensive endeavor, however, and some parts of the country are simply not equipped to treat their water sufficiently. This economic imbalance between cities or region creates large gaps in the overall water quality across the United States. Water contamination is a very real problem in the United States today. The U.S. ranks 36th in overall water sanitation worldwide, and much of that is due to the incredible diversity found throughout the country, whether that be geographic or economic. Ultimately, it is up to everybody to take responsibility for their water. Individuals need to use water conservatively and ensure they don't contribute to polluting the water supply. Farmers need to use safe and responsible techniques for maximizing their crops. And the government, both local and federal, need to realize the importance of clean treated water and see to it that proper funding is given to clean our nation's water supplies.